Hey everybody, happy Monday. It is noon here in Austin. Beautiful day outside. Hopefully it is a beautiful day where you are as well. And I hope you're having a great start of the week. Got some fun planned today. Actually going to do two major things. I am planning today on wrapping up the Brew Buddy project. It could go on forever and ever if I really wanted it to. There will always be more to do than I have time or ability to do. So I am going to declare that today will be a stopping point, and I'm going to spend the first hour of my stream working on a few more firmware things. And then I'm going to move on to a new project in the second half of the stream today. So that should take us through the 2 hours, the 2 hour block that we have. So that's the plan, and hopefully it'll be good fun. So let's start with Brew Buddy and specifically talk through Electric IO. If you were here on Thursday, hey Grogard, how you doing? Good morning to you. Hope you had a great rest of your Sunday evening and having a good week so far. On Thursday, I submitted this pull request. You may recall. This pull request to Electric IO. The idea with this pull request was actually to enable you with these button cards to be able to send in message payloads. The default functionality in Electric IO was to support direct messages, and so we added on the stream last week some capability to actually choose cloud to device messages, send payloads, and do that. I submitted that as a pull request to NoopCat, to Suze Hinton, who is the creator of this awesome project. And she actually reviewed it on her stream yesterday morning. And I will do a shout out for NoopCat again. So that was fun. I was actually on her stream yesterday, just hanging out, not on, but like viewing the stream yesterday. Hanging out with her awesome community of folks, and we got that merged, and that's now part of Electric IO, which is very cool. So that pull request was closed. We have, excuse me, that functionality in the main line of Electric IO right now, so we're good to go. And this is what our dashboards look. I actually pulled down from master this morning, and let me move my camera down here a little bit. Pulled down from master this morning. And everything looks good. So I'm running Brew Buddy here on the big screen, as you can see. It's been running for a few hours this morning, just reading temperatures from my sensor that's just sort of sitting out by itself, not doing too much. And the dashboards are looking really good. So in terms of the things that I actually want to do, the rest of the first hour this morning, they're listed here. So these are the pieces that we did on Thursday that are done. There's now sort of a single payload, and if you look at the particle console for my Brew Buddy component, or for the Brew Buddy device. Let's see. We'll call check temp on there. Check rate. Oh, it's not in the right fermentation mode. That's right. So I'm gonna leave this open for a couple of minutes, just so that we can see the payload is actually posting every 2 minutes now. Oh, actually, never mind. I can show it through the integration. So we have the integration set up. Through Azure IoT Hub, the integration is set up here, and the way that ends up looking like this: temperature, fermentation rate, and battery charge that are going across every time, and that's all working great. So I'd say that the electric I/O piece is good. I'm happy with it. I'm happy with the way the dashboard looks. There's a few firmware pieces that I need to deal with now. If you'll recall, when I go into fermentation mode, one of the features of moving into fermentation mode, and here actually, let's go into fermentation mode from here, from electric I/O. We'll run that. Oh wait, you know what? I need to get a new, that's that later. We'll go into fermentation mode from here. There's what the payload looks like. But now let's actually go into ferment. And when I do that, that turns off the device. But what it doesn't do is turn off the screen, which is an important thing. The whole reason why I'm going into fermentation mode here is to save my battery while I'm waiting for fermentation mode to actually begin on the device. If the screen is still on, my LiPo battery is not going to last me nearly as long as I need it to. It wakes back up when I tap the piezo. Excuse me for also bumping the camera. And I get a fermentation rate. But what I want to do in firmware right now is actually turn off the TFT when I enter sleep mode. So where sleep mode actually happens is if I am in, where does that happen? Okay, so this is in my loop. Give me a second as I figure out where this is. There it is. So system.sleep is going to happen here, but before I do that, so I'm going to write waiting for fermentation. I'm going to put in a delay of 2 seconds to allow that message to show, but then from here what I need to do is turn off the screen. And that should be possible. Are you powering the LCD's backlight from a pin? No, actually, good question, Grogard. The backlight is not powered from a pin. Is that going to affect my ability to do this? Do I have to have it pin controlled in order to turn it off? Because you might be giving me another excuse to... Hey, Bug Bicho, thank you so much for the follow. I appreciate it. That's awesome. Welcome in. Thanks for coming and hanging out. We're working on some device firmware today. I really do appreciate the follow. And feel free to jump into chat and say hello. We are a kind bunch of ne'er-do-wells here that love to just hang out and talk about hardware, software, firmware. Yeah, the LC, it does have a pin for the backlight. So it is the, it's the very last pin on the breakout. It is not currently wired. So, Ah, I can't turn, you're right. I can't turn it off if it's not wired, can I? I smell a bodge in the making. We might be bodging something today. Which would be kind of fun, wouldn't it? Yeah, there is. So for instance, so Grogard, this Adafruit IL9341. That's the one. That's the one. No, it's not this one specifically. It shouldn't be an issue. Here we go. No, it's not the 2.8 TFT touch shield. Here, TFT 1. The 2.2 TFT. So you're not sure the board can drive that output? Maybe not. Yeah, that's a good good question. So this is it, close up, and the backlight pin is right here, and that's the only pin that I'm not currently using. It's not actually wired anywhere, right? I skipped it, much like I did the SD last time, which maybe that was dumb. So you think it's so without using the without using the backlight pin, it's going to be hardwired to 3.3, which means I do need to bodge something into that in order to make that work, wouldn't I? Here, let's take a look at the ILI library. There isn't any. So that's what or it wouldn't be on. Well, yeah, you're right. You're right, Grogard. It wouldn't be on right now if it wasn't hardwired. And it's going to be on all the time probably, right? Because the TFT header does not actually provide a way to, like, here, if I'm in here, TFT dot, as far as I'm aware, yeah, there's not a public method for turning this off. So I do need to wire that to a pin. You're right. I'm not going to need to cut a trace. I can bodge it in a different way, maybe. I've used these type of displays. Oh yeah, no, I do appreciate it. This is great. So yeah, so the way that I'm going to need to do this is, hey, Frackberg, happy Monday. How are you? Hope you're doing well. How was your 5 a.m. wake up? Yeah, so let's do like, So you're talking about... Oh, Frackberg, you and I had the same morning then. My alarm was set for 10 till 6, and I rolled out of bed at like... I totally slept through the alarm this morning, which I never ever do. But I did this morning. So I'm with you. Not great either. Managed to recover a little bit. So Grogard, you're saying that there should be some cuttable traces actually on the back of the TFT, of the breakout. Let's look. And there are. Oh wait, I do have the backlight wired up. What now? Oh, you know what I did? Thankfully, I had a dog jump on my face to finally get me moving this morning. Dogs are good like that, aren't they? Let's open up Eagle. We haven't done that in a couple of weeks. What display is this? So it is at Adafruit 2.2 inch TFT breakout. That's what this one is, and I was looking at the backlight. So what Grogard and I were just talking about was actually getting the backlight. Yeah, look. So pin 10 is the TFT. Or sorry, it's the backlight on the TFT. Hey, the Michael Jolly, how are you? Happy Monday. Hope you had a good weekend. Fragberg, I think I have a use for a screen about that size. Oh yeah, these are great screens. I have a couple. I have used a couple. They're pretty nice. So yeah, so this is the backlight, and I finally, oh, you're over the head cold? Good. I'm glad to hear that. So that's good. Hey, morning.commie. Hey, Siva, welcome in. Hope y'all are having a great Monday so far. So we are, for those of y'all that just came in, I did recap briefly that all the electric I/O stuff is working. I did manage to get the pull request that we created on Thursday. Sue's actually merged in her stream yesterday, which was a lot of fun. It was awesome. For those of y'all that had a chance to be on her Sunday stream, it's always a chill, fun time. So I was able to be there for a little bit of that. Got that incorporated. So our dashboards are great, are good to go. And now what I wanted to do today is two things. I wanted to spend the first hour or the next 45 minutes trying to cover a couple of these small little bugs. Small little bugs. But it is time today to be done with Brew Buddy. For now anyway. But I want to finish it in the first hour today and then spend the second hour on a new project. A brand new project that's actually related to this. Oh man, this thing on the wall behind me and a Twitch bot. That's what we're going to do in the second hour. And so where I am right now is realizing that I wanted to, for fermentation, actually turn off the TFT screen to save battery. Because right now it sort of says, hey, waiting for fermentation. The device goes to sleep, but there's still 3 volts going to the display and it's still on. We were chatting about this just now, and I realized with Grogard's help here that the backlight is actually not, I didn't bring the backlight pin into the board for the PCB. Which means we're going to need to bodge it, which could be kind of fun. However, Grogard, I don't want to go down that path if you're thinking that's not going to work. My plan at this point So you'll see I'm actually bringing pin 10 into the board. There's just not a trace anywhere. So what I was planning on doing as a cheat was, see if I have a GPIO here. I have 11. What's GPIO 11? So that's one of the digital pins on the board. So what I was thinking of doing was actually taking this wire here for the backlight pin, cutting it, and just trying to solder right in to the bottom and seeing if that works. However, I'm not really set up to do that right now. You can cut the current 3.3 that's going to the backlight. And oh, I see. Okay, I'm with you now. Sorry, I'm being dense on a Monday morning. So what you're saying is, if I continue to power it from the 3v3 that's coming from the Argon, it's going to stay on. But if I try to power it from a pin to the board, that's where I need 30 milliamps. And let's check the data sheet for the Argon, because I can't remember if I get 30 milliamps out of these. Okay. Out of any of the GPIOs is what I'm looking at specifically. Oh. I can't remember what the draw is on all these. You can cut the current. Yeah. So a resistor in line might help. It'll be dimmer. Yeah. So, okay, Grogard, this is where my saner self says cut and run. Don't try to do this on the stream. So I'm not going to try to do this on the stream. I want to do it, but maybe we'll, oh man. See, this is why you have to sort of just declare things done at a certain point. However, that's kind of an important feature. So instead of doing this today, I'm going to move this one down. I still want to do that, but it's going to require a little bit. It's fun to see how my second cam is adjusted. Is it still doing it? Ah! What's funny is right now in my headphones, it sounds like it's doing it to the beat of the music. It's like a heartbeat. Oh, it's annoying. Why? Maybe it's because it's too far up. Or too close. I don't know. It's going to keep on doing it. All right, that's slightly better. Okay. So then let's move on. What I'm going to do instead is check my battery state logic. Right now I'm at about 95%. What I noticed last week, all right, so this is not happening today. Not on stream, because I really, really don't want to let myself get buried in that. My battery charge is about 95% right now. What I was noticing the other day is that it didn't seem to really ever go under 71%, which I know is not the case. Like I was running on a LiPo way longer than it should have stayed at a single percentage reading. And so I think I have a bug in my battery state logic. So I am going to mess with that. if I can find it. Okay, get bat percentage. Oh, why did I uncomment this? Huh. I think that needs to be in there. Okay, so get battery percentage. Right. So, DC Shell, thanks so much for the subscription with Twitch Prime. I always love getting to see David Tennant up on the screen. Yes, on the screen. Yes, .com, thank you. Thank you for the Trash Panda, Cyan Panda swag. Thanks so much, David. Thanks for jumping in. It's okay. It's okay. I'm glad you're subscribed now. I appreciate it. Okay, so here's my logic. So I'm reading from the battery pin, and again, this is coming straight from, shut these down. 2 tabs open. Simple voltage divider here in the Argon. But I can at least read from the battery pin, multiply it by this constant .0011224. So and that gives me a value that's read by the ADC. I'm going to do a So I'm wondering why I'm never getting anything below 71% here. And what's it reading right now? Is it still reading a 95? I don't know. Hey, Robert Tables. Good morning. Happy Monday to you. Hope you had a great weekend. And once again, nice stream on Saturday. I was in and out towards the end, but Saturday yard work and whatnot, but it was fun. I think I got a buddy at work interested in trying out Particle. Awesome. That's great. What's the, any ideas for the project? Yeah, Saturdays and Sundays. So I ended up, like I've started on my weekends to sort of balance a bit of, like always have stuff to do on the weekends, but I try to schedule in downtime in the office while I'm doing those things. Like yesterday for No Upcat stream, I had it on almost the whole time, but there was a part of that towards the beginning where I was like driving towards an at-Home Depot to buy a new edger, assembling it in my office, hanging out, watching for a bit, out in the yard, all that kind of stuff. But you know, that's part of the fun. Introducing Apple Card. Oh, am I competing with the Apple event today? My gosh, I didn't even think about that. I haven't watched an Apple event forever. Well, .com, keep us updated then. And what the heck is Apple Card? I'm not pulling up any browser tabs on this. So I'm just gonna have to rely on you, .com, to tell us what's up. Okay, so I'm multiplying my voltage by, dividing by 4.2, multiplying by 100, adding a half. I really want to, troubleshoot this a little bit. So let's do a particle publish and let's Let's just get the actual voltage submitted. No firm ideas yet, but a few float around. Awesome. Well, you know how to find me if you ever need any help or suggestions or ideas or anything like that. Okay. What did I do with my flashing cable? Did it fall? Oh, it did. Just a moment. I know that I'm in this sort of hacky state with flashing. Hey Dremic, how are you? Welcome, happy Monday. Hopefully you've had a good one. I know it's closer to the evening time for you, Dremic, but hopefully it's been a good, or was a good Monday so far. Still is. Let's go ahead and flash. Yeah. Apple Card. Apple, it's the best Apple Card we've ever made. I know, Apple. Error. There's no firmware error, you liar. All right, there it is. What did I do? Oh yeah, this has to be a string. Oh, compilers. All right, flash it again. Okay. All right, so now I want to get what I should be getting whenever I come back online. I should be getting a pretty reliable, I should at least get sort of the raw voltage that comes in. So if I check the battery, okay, 4. Okay. So 4 volts is what I have. And so, that makes sense, right? Let's double check the logic here. With the old calculator app. So 4 divided by 4.2, 95 times 100. And then I'm doing plus 0.5 to save myself some silly rounding. So 95%. Apple Card. So now I'm just seeing a Verge update pop up. Apple announces the Apple Card credit card. It probably has a 75% interest rate. Daily cash back. Interesting. I forgot to put on my safety coating glasses. Okay, maybe that's what... 75% interest rate and a 5% cash. Apple Pay and PayFriends integration. Interesting. Okay, well, actually, I feel, given all of that, I think this logic is actually correct. I'm still not entirely certain why. I mean, the voltage is not changing a lot, which is, I mean, it's fine. I'm not doing a ton of. We removed the magnetic strip. Yes, they removed the magnetic strip, and it is instead replaced with a proprietary, slightly looks like USB-C connector. And you have to pair to it via Bluetooth. 30% charge, 30% of your cashback payout. That's right. Yeah, so GrowGuard, it is right, this particular one is 2,000 milliamps. You need a dongle for it. That's right. So this is a 2,000 milliamp battery. I'll drain the battery more if I go into brew mode, because I'm updating the display every second on that. It needs a new pocket. That's right. And you gotta buy that. That's right, so you buy the dongle separately. So I'm doing more on the screen in brew mode. But maybe this isn't anything for me to be concerned about. So, however, GrowGuard, double check me on this. I started running this under brew mode like 3 hours ago. And it reported 95% this morning. I mean, I'm rounding here, right? It reported 95% this morning, and now 3 hours later, and it's been mostly powered up this entire time. It's been running 95%. That feels like it's not correct. Like I'm not a embedded power expert, but it feels to me like it would have at least dropped a percentage or two over the course of that 3 hours. It will run for a really long time on that battery? All right, well then I need to just trust that everything's fine. And I also need to subject this to real world conditions, which means I need to brew some damn beer and not just keep on tinkering with this. That's the problem. That's why in 24 minutes I'm done with Brew Buddy for now, when we're moving on to another project, because it's time. So I'm closing this one. We're gonna say I've double checked it, and we're gonna say it's fine. No fix. No fix. I do, however, know that my math on fermentation is raw on. So that's the next thing I want to check. And then this other stuff I'll worry about another time. So I'm going to pull this out. Okay, yeah, fermentation rate is what I'm looking for. Yeah, okay. Okay, so here's how fermentation rate is getting, yeah, Wi-Fi absolutely does eat most of the battery up. And probably what partly helps here. Drop to 200 milliamps on a transmission, yeah. I'm only doing posts to the particle cloud every 2 minutes. So even though the screen is refreshing a lot and it's reading the temperature constantly, I'm not doing cloud publishes a lot. And that's probably why it's gotten, the battery is sticking around longer, because I'm not having to worry about that as much. So getting the fermentation rate, so here's what happens. Let's, anytime that I'm in fermentation mode and I get a knock on, not on that. I'm so sorry. I'm going to keep on. I need to move that camera. I thought yesterday this was a better position, but it's killing me. Or maybe messing with y'all because it's just messing around. Okay. So if I switch, let me switch back into fermentation mode. Yeah, it's great. Having the Wi-Fi in sleep as long as possible is ideal if you want the most battery life. Yeah, which is part of what I was getting at with fermentation mode, putting this thing to sleep. Because right now, it's off, with the exception of 3.3 going to the screen, like we talked about. I'm not messing with right now. It's just waiting for fermentation mode to trigger back to life. So what happens now at this point, now that I'm in fermentation mode, is every loop through, it's checking a knock. It's reading from this analog, from the knock pin. And when I tap on it, I am placing basically the rate, the current millis minus the last knock time in an array. So the number's getting lower because I'm knocking it relatively frequently. So right now it's down to like 8. And the way that this is calculated, so I'm explaining this a bit so that I can get to that. The way that this is calculated is I have a queue, basically, and this queue is done via the queue array. It's a queue array. What I'm doing is I'm going through every item in this array, in this queue. I'm dequeuing, creating a sum, getting a sum, in-queuing the items back in, and once I get through, I'm doing a sum divided by the array count. Which I think makes a lot of sense. I mean, that was at least the theory. The problem that I've noticed, and we'll see if I can replicate it right now. See, that number got even lower. It's still it's now a 6. So here's what I want to do. So I'm going to count the numbers of the items in the array. I'm going from the first item, I'm dequeuing it to get the current value, adding that to the current sum, and I'm in-queuing it back into the array. And I'm getting a, fermentation rate 6312. Grogar, I've been doing lots of power monitoring and batteries. I bet you have been. A whole lot. Okay. If anything boneheaded stands out to you all, please feel free to point it out. Because I'm reading this right now and it makes sense. The logic there, I think, is sound. However, again, it's been a little while. Oh, now the number's gone up. Maybe I just waited longer this time. And that's what I expect. If there's longer breaks, I expect to see that number go up. If there's shorter breaks, it should go down, right? So now it's a 0, though. What the shit? Excuse me. Half my keyboard style. Oh, Frackbird. Which half? The good half or the bad half? That's no fun. 080. So now there's no way that I've gone all the way from 9 to 080. And now it's a 3. So I'm doing something horribly wrong here. Kind of need both halves. You do. It's true. You need both halves of the keyboard. 395. Six now. See, I don't understand what's happening. I filled my last keyboard with a full mug of coffee. It somehow still works. Oh, golly. That's an impressive keyboard, Grogard. It's not an Apple keyboard. Or maybe it is. I don't know. Is it an Apple keyboard? Michael, you just need to be more efficient with the half you've got, Fragberg. That's right. Michael Jolly is correct. In fact, you know what you ought to do, Fragberg, is just function map everything on the broken side to, you know, Control Alt keys on the left side or on the other side, and it's fine. It's a challenge. Four. Here's one of those weird programmable boards. Those are the best kind. You know what? No, but it's gonna go out of scope. I was gonna say maybe the problem here is that I never clear out the sum, but the sum goes out of scope as soon as I return the rate. Michael Jolly, that's pretty funny. Dang. Ran the keyboard through the dishwasher without soap and it worked like a charm after getting a few days. That's impressive. I have never heard of that dishwasher trick, but I like it. And well, Robert Tables, I had the rice thought too, actually. That was my, because my wife did that one time with her iPhone and it miraculously worked, but it took several days. That's crazy. Okay. See, Michael Jolly, that would be my attitude. Is I would tell my wife, it's really, I mean, what else can I do? I gotta get a new computer. It's just, keyboard's totally disconnected, but I need it. They work together. They're a matched pair. They're a matched set. Okay. Is there a chance that I am... It's soda and a laptop keyboard. Oh, yeah, that's bad. Oh, that stinks. Sorry for going silent here. I'm looking at this and I am just trying to rack my brain. Why now all of a sudden I'm getting a 1? You know what? It has nothing to do with this. I think I need to debounce this thing. So I think what's actually happening here is it's not this. I think this logic is correct. I think I'm getting too many inputs. I bet what is actually happening is anytime I tap this, it is reading, because it's an analog sensor, it's kind of like a button. It needs to be debounced. And what I mean by that, so Robert Tables, here is the idea behind debouncing. Anytime you use a input on a embedded device, whether it's a switch or a button or something, the way that works mechanically is that there is like when you press a button, I wish I had one in front of me. When you press a button, it actually makes contact with the switch, like with the mechanical contacts, and then comes up, and then makes contact and comes up, and it does it faster. So what happens is the button actually bounces before it makes a firm contact and completes the switch. And debouncing in firmware is a way of basically telling your program to wait before it decides whether or not a button has been pressed, right? And there's a good graphic for this. Where did I find it? There was a nice graphic for this I found recently. Oh, maybe Adafruit actually has a good one. Yeah, Grogard, I think that maybe I ran into that on Arduino with a button and never really figured it out. So yes, this is kind of what it looks like. So if you were to look at what happens when you press a button, and this is the kind of button I was thinking of, on an oscilloscope, what you see is the switch starts out low, and that would be sort of in this case, the unpressed state. And then when you press it, it actually bounces up and down for a little bit. In this case, it's showing only like 1 millisecond. So it's super, super fast before finally settling on pressed or high in this case. And analog inputs tend to work like this. So I think what's actually happening with my disc here with the piezo is, if you look at it this way, every one of these things is going to end up in my array, in my queue, because it's going to read that voltage and it's going to pull it in multiple times. I think that's what's happening. So a debounce library actually makes it easier for me to wait for that until the switch settles on the state that I want it to, right? And so there actually is a good library for this. It's just called debounce. I don't know if that, tell me if that makes sense, Frackberg. And Grogard and others that y'all have done this many, many times. Feel free to add if I'm explaining it poorly. So the way that the debounce library works, if you look at this example, is I'm attaching my debouncer to an input and basically saying this pin, I'm going to debounce it. I'm only going to wait like 20 milliseconds, but that's a whole lot of time in microcontroller world for a contact to jiggle up and down before it's actually properly connected. And so when you actually do the read, yeah, but this is a digital. Maybe I'm wrong though, because this is an analog. Groger, I think it's definitely worth a try. It's the only thing I can think of at this point. So whether it's sound logic or not, it seems like well, it's still reading, Robert Taylor, it's actually still reading from this digital pin, which is how I've used it before. So I'm wondering if maybe I'm down the wrong rabbit trail here. The digital right, in this example, it's just turning on an LED when you press a button. But maybe. My device is analog, yes. Yeah. And it is, yeah, you're right. It's an analog device on a digital pin. But in this case, this button is just low or high. Yeah. I got you. All right, so let's give this a try. Right, because ultimately what I want to do is debounce. I want to debounce an analog read. Which that may be that there's another. I think I'm on a rabbit trail. Because this is what I'm checking. But I would think it should work because it basically checks for a state change, and then if the time between changes is too great, it ignores them. It's too small. And you know what, Grogard? I think you may have hinted, you may not have meant this, but I think what you're getting at is my issue here. I am sort of in the right headspace with debouncing, but I don't need to debounce here. What I need to do is filter time differences that are too small. That's what needs to happen here. Because this value is just filtering out knocks that are digital noise or analog noise. Any analog value under 6, I don't care about. It's noise in the system. But what I ultimately need to figure out is the difference between the last knock here. If it's too small. Yeah. That's the loop that runs way faster than we understand. Absolutely. It does. It does. You're right, Robert Tables. And I think because of that, the loop is going to catch multiple knocks, or it's going to catch a single knock as multiple because of how fast it moves. So I think what I need to do is, here's what I want to do. I think ultimately what I want to check for is I want to filter out any knock that happens within a range of like a few milliseconds, 20 milliseconds, let's just say. So let's go up to the top and let's add another, where's all my, let's just call it this. And we're just going to say define, we'll call it knock delay. So anything that comes in was that for me, Grogard? I've read that. I've read that tutorial before. I know that. Oh, okay. This is the manual debounce, right? Yeah, I mean, this is effectively the source for doing debounce yourself. Yeah, read the state to switch. I mean, I am sort of implementing a bit of a debounce myself. Or Groger, maybe you're talking to Robert Tables and not me. In which case, thank you, because yeah, that's a good resource. So here's what I want to do. So I want to do if millis minus last knock is greater than my delay, my interval. That's an else if. All right, so let me look at this and talk to myself out loud here. So if I get a current millis reading, right, what this is saying basically is any knock interval that comes in that's greater than, or that's within 20 milliseconds, a really brief period, then don't even bother adding it to the array. Therefore, the fermentation rate will not be calculated. I think that's legit. Let's see if that helps. Come on. Okay, yeah, flash. Let's do a flash real quick. Oh, now it's come. Oh, crud. This is going to take a second because I still have the debounce library in here. That's okay. It's okay. It's okay. Still flashing. Okay. The internet's being wonky, not sure if my last message went through. The last message I saw, Grogard, was the Arduino debounce example uses millis and similar to probably what you want. I don't know if that was the last message you sent. All right. So we're good to go. Let's go into fermentation mode here in Electric I/O. There was another, but okay. All right. All right, so I'm in fermentation mode now. My device has gone to sleep. Waking it back up by just smacking it. Smacked it on the side of the head. Now, if I check my fermentation rate, I shouldn't zero, right? Because I'm not getting a rate yet. 15. 15, that's good. 12. Okay. Wait a few seconds. 2, 3, 4, 5, 6, 7, 8, 9, 10. 14, it's going up. 14.19. Just do a graph in here for fermentation rate. Okay. 14 still. Okay. So I feel good. It's a little higher, so I waited a little bit longer. I think this is right. So I think I've actually managed to, with this change, filter out. Because if you'll notice what's happening here, when I tap the disc, and that took it all the way down because I tapped, oh crap. I may need to set my interval higher. 2. Because you notice how it is kind of moving a lot. Thanks, Michael Jolly. I mean, if it works well, it'll be cool. I'm gonna set my rate higher. I'm gonna set my interval up to like 50 milliseconds. And this is one of those things that, again, like I need to brew some beer to actually like test this out for real. But that's a pretty, like what typically happens with the airlock on the top of the carboy is that fermentation will go, I want to read, I want to catch this speed, but not that speed because I've never experienced that before brewing beer. So I could probably take the knock interval even higher, but I think I'm on the right track. I feel pretty good about that. Just need to have a higher value. Really, what, Frackberg? Have you seen, like, yeah, when I'm getting like this. Grogard, no, the sensor is actually going to be on the top of the airlock. I'm going to tape it to the top. Or at least that's the plan at this point. So, Frackberg, when you have brewed beer, do you get like, and this is again like ales. I mean, I've seen really active fermentations, but not like knocks within like less than 50 milliseconds apart. That would be like insanely fast, right? To the point that I gave up on airlocks and just do a blow-off tube. Really? I have not. I'm not opening a browser tab to look up blow-off tubes. I'm not doing it. I'm not doing it. Let's flash one more time, and then we're gonna call it good because I want to move on to the next project. Mead, that could end badly. Yeah. I hate how stiff these LiPo connectors are too, Grogard. You are absolutely right. It's just a tube that goes... Oh, interesting, Frackberg. I'm gonna have to look into that sometime. Yeah, I don't like these LiPo... Oh, drive me nuts. Robert Tables. I've only ever brewed discontent. I'm a developer. I like that. I like that. Oh wait, did I not flash? Oh, now it's gone. It took a second. Okay. In place of the airlock, we've had too many fouled airlocks due to fermentation. Maybe I just haven't brewed enough, Frackberg, that I haven't experienced a lot of that. I go through phases where I'll brew several batches of beer, and it's just so time consuming, but I love doing it. I really do love it. It's fun. All right, I'm gonna go into fermentation mode. Ferment in two. I mean, I do. What do you? I mean, I'm using like around. I'm doing about 5 gallons of beer at a time. Okay, come on, wake up. That's weird. Robert Tails, my dad used to brew beer. Woo boy, did that stink of our kitchen. Yeah, so I started doing the boils and all that stuff outside because I was commanded to get out of the house with it. Ferments like a... I go through cycles too, Frackberg. 3 to 4. Yeah, absolutely. Oh, Grogar, that sounds good. So mead is something I've had a good bit of it. Never made it. Never fermented it. Sounds like it would be good. All right. I'm calling this good. It's at the point where real world testing is required. So let's check this in and then move on to the next project. So no. Robert Taylor. Dilly, that's pretty funny. I've heard it's easy. I have some friends that are big into it. Let's see. Implemented filter on knock detection. Closes number 36. Oh, I'm in master. Crud. Well, y'all don't look. I'm pushing master. I'm breaking my... It's my repo. I'm the only one that commits to it right now, but don't tell. Okay. So that's going to do its Azure pipeline business to go and do the build and all that stuff, and that should be fine. I'll do another release. But I think we're good. It's actually, we're going to move on to something else now. I am super excited about this because, as I mentioned earlier, it relates to this madness behind my desk here. This, oh, what the heck? There we go. This pegboard wall. I have christened the wall of things. So right now it is just an empty pegboard with 4 NeoPixel strips, and you can see there are 4 particle xenons around it that are each controlling the strips independently. So the next project that I want to work on, hey Rhinoceros Rex, welcome, happy Monday, and thank you, I appreciate that. So now that Brew Buddy is done for now, hey Michael Jolly, thanks so much for the host, I really appreciate that. That's awesome. So the next project that I want to work on is, over the course of the next several streams, probably a few months or so, is we're going to add some stuff to this. I am actually going to add the Brew Buddy to the wall for some like automated testing and whatnot. But I have a few other projects in mind, panels, a plant monitoring and watering system is something that I want to work on the stream. But one of the things that I want to do today is actually start making these NeoPixel strips controllable. And controllable via a Twitch chatbot, because every Twitch stream eventually has to get meta and implement tooling for the stream itself, and that's what we're going to do today. So I'm going to show off this project. It is like I mentioned, the wall of things. So we're going to go into a particle. I should be in master, yes. Have I not pushed this yet? Oh, interesting. Hold on. So, let me go to my GitHub for this. The repo for this that I'm going to start working on is here. Maybe I actually just put it under... Huh. All right. Forgive me as I figure out where the heck everything is in GitHub. Move this down here. All right, so I have stuff in here, and I guess I just have not pushed to origin or added origin or pushed to it at any point recently. So there's a couple of pieces here. I have firmware. In fact, let me just open those up separately. So the firmware for this wonderful wall, there's 3 pieces to it, or 2 pieces to it right now in this workspace. Each of the individual NeoPixel strips, and then a controller. The controller app basically just does the job of dealing with mode settings and then setting animations effectively. So the way that each of these strips works is when I set the strip mode, I can set it to, hey, I am not myself. Thanks so much for the follow. I appreciate it. Welcome. Thanks for coming in and hanging out. You know what? I think that actually takes me to, that puts me at 199. So like 1 follower shy of 200, which is kind of cool. It's kind of fun. If there's somebody else watching that sort of feels like being number 200, I wouldn't stop you. I would be forever in your debt for being number 200. It's okay if not. It's okay either way. But I am not myself. Thanks so much for hanging out. Welcome. So thank you. So what's happening right now is when I say, yeah, I have two particle functions here, one for set mode and one for chase. And set mode, basically, there's several different modes on each of the strips, and set mode just tells all the strips to do something, right? Oh, like a little gritty emote. That's awesome. I love that emote, and I loved hearing the story. Oh, sweet. B3 bot. I just got, is number 200 a bot? Are you a bot or are you a real person? Either way, thank you. And hey, I am not myself. So is that Auth0 Bobby? Did you rename your handle? Or is that a separate, is that like a personal account? $200 may or may not be a bot, the Michael Jolly. Yes, it did. Oh, cool. All right. Well, very nice. And so what the chase does is it starts the animation that you see right here. So there's actually several modes on the individual NeoPixel strips. And I have some defines that manage them separately. Rename to match your other social media accounts. That's cool. Yeah. I like the I am not myself handle. I think that's a good one. So there's a few different things to this, to the actual strips themselves that run individually. I have a Adafruit NeoPixel on my desk that there's one animation where I can actually hit these buttons on this NeoPixel. Here, I'll actually show y'all. So maybe let's, I'm going to give you a little bit of a view of my desk here for a second. I'm going to turn this camera off and turn this one on. So you can kind of see, can you maybe? I can bring it closer. I have this, oh, that's not great. Is it any better? It's not, it's terrible. I have a NeoPixel, or excuse me, this Adafruit Neo Trellis. Yes, and of course a Stream Deck. There's always got to be a Stream Deck. Let me go into like big desk camera. Okay, maybe you can see that a little bit better. This is an Adafruit Neo Trellis. It actually is hooked up to a particle xenon here as well. But one of the features that I have on here is that each of these buttons is color-coded differently. And there's an animation on here that will fire all of those strips, all the lights behind me, whatever color I actually press here on the Neo Trellis, which is kind of fun. It's pretty neat. So that's one thing. That's one feature, one animation that it does. So let me go back, turn that one off, and yeah, turn the big camera back on. What's the Orlando CC, Siva? Is that a user group in Orlando? So that's one, playing the trellis value. It'll also sometimes will play back like random values. Tone thing is a little bit different, but then the chase piece is basically what happens on the chase function is it just runs through a color all the way from start to finish. So it sets, right now it's setting a pixel color of cyan, but we can actually mess with that. And then when it reaches the end of one strip, it publishes a message to start the next one. So it reaches the end and it says, okay, next strip, it's your turn. That strip listens for, oh, Orlando Code Camp. Yes, I should have thought of that. Yes, Orlando Code Camp. Oh, fun. So that's what's happening there. That was sort of a long prelude of introducing like how the wall actually works. The important thing, and what I wanted to mess with now, is not that functionality per se, but actually starting to build a Twitch bot that will allow the chat to control that light wall. So there's going to be a few things that we'll be able to do. This is sort of the beginning of what will be a whole lot of stuff on this wall. But what I want to do today is allow the chat to trigger the chase, and then also to set the color of the light chase that goes around so that we can sort of change that at runtime. Robert Tables, I appreciate you sharing how some of this works, even if you explained it on previous use. Oh, thanks, Robert Tables. I appreciate that. I'm sure you get this way too. I go through these moments where as I'm saying these things, I'm like, maybe they've all tuned out because I feel like I've said this 100 times, but I try to like add as much context as I can. And also partly it helps me remember what the heck it is that I'm doing. So thank you. I appreciate that. Yeah, the chat-enabled LED snake game powered by Particle. I love it. So as I was looking at chatbot stuff, there's a couple out there. There's this Twitch bot on NPM. I'm going to do a node-based chatbot, basically. But it looked like if you go to the Twitch docs that TMI.js is the way to go. So that's actually what I'm going to use. Yeah, I mistakenly assumed too much knowledge from viewers, so I'm working on being better about explaining things. I think it's a tough balance. It's a tough balance for sure. I appreciate it. I think you always do a good job of explaining stuff. And I definitely try to do the same. So I'm going to use TMI.js. I think that's the way to go here. So we're going to start with creating a new, let's see here. I'm going to create a new directory here in my project, right? And we're just going to call it the Wattbot. Wattbot, Wall of Things bot, right? CD Wattbot. And npm init. Package name, Wattbot. Version. Never, ever start, I never ever started version 1.0. Probably don't get there fast enough either though. Go bigger. 0.01 description. A Twitch chatbot for controlling my wall of things. Sure. Sure. No. Haven't decided yet if I'm going to put this in a separate repo. I've been doing a bit of like the mono repo thing lately. And I was trying to do like a single repo for everything. And I haven't decided whether I like that or not. So I don't know. I'm just going to stick with it for now. And then the Git repository will just be this. I reserve the right to change it later. I don't know. Author. Me. MIT. Yes, it's okay. All right. And I have my lonely little package JSON. So let's drag this over here. Twitch Play Snake, sponsored by Brandon Satcher Sport. Hey, absolutely. That'd be really funny, and it would probably also like fry this thing. All right, so I know for a fact there's already two libraries that I'm going to need. I want TMI.js, and I do believe the way that I install that is just npm tmi.js.save. Oi. Okay, so I know I need. Cool. All right, that wasn't too bad. New minor version of npm is available. Okay, that's cool. And I also want the Particle API.js. So Particle API.js, I believe, is the. I think I would have installed this enough time that I would remember it without having to look it up. I think it's Particle API.js. Twitch brews beer. Also a fabulous idea. This is going to start as a pretty basic app, and then we'll improve it over time. Oh, I also know that I want .env. So npm i.env. Because I'm going to have me some secrets. We all have secrets. This project is no different. Oh, it'd lead to a hack in Twitch sings. It would. Dangerous. A dangerous Twitch sings. It's funny. Here, I'm gonna move. Dang it. I'm moving the camera. Oh, I need to get the desk camera out of here. No! Okay, sorry. Never mind me. Hey, KL65US, thanks so much for the follow. I appreciate it. Hope you're having a great Monday. We're here hanging out, working on building a new Twitch bot to control this wonderful pegboard wall behind me right now, at least the NeoPixel strips that are on there. So it should be fun. Feel free to say hi if you want. No worries if you don't. Thanks for watching and thanks for the follow. Is .env like the largest NPM package ever? That is right, isn't it? Isn't it .env? November perfect mustache. I just forget I can come to NPM all the time and get this. What you got for me, NPM? Neanderthals programming machines. Name picker malfunction. Non-deterministic polynomial munchies. Yep. Yeah. Ah. Okay. Yeah, it's right there. .env. npm install.env. Oh, it worked. Yeah, now it worked. Okay, so TMI.js, back to this. Let's look at this example. Yeah, here we go. This is what I want. If I have something like this. Let's copy some code. Line by line, why not? So const, I know I'm gonna do const particle equals require particle API.js, single quotes, please. And I'm gonna pull in .env as well. Back from a series of conference calls. Kami, I am so sorry. Welcome back. How long were you gone? I mean, we've moved on to a completely different project now. Brew Buddy is done. Done. When you're working on a project by yourself, done is whatever you want it to be. But I needed to move on. So I'm actually working now, I'll get that eventually, on this, on my wall. I'm started building a Twitch bot that's going to allow us to control the lights on this thing. If I can actually get it wired up in the next 30 minutes, I'll be so excited. Ah, that's Mondays for you, right? Mondays end up being kind of nuts. All right. So we'll do a .env config. Great. I need my configuration options. Let's go ahead and pull this in. I hope so. I hope if I get it, if it'll be cool if I can get it. What in the heck? Oh yeah, if I can get it working. All right, so I have a bot already. It is actually the same bot that uses the Twitch chat highlighter. That's the Cyan Panda bot. And yes, you are ready to highlight some code, aren't you? So, Cyan Panda bot. And it needs my OAuth token, which I'll go and get here in a second. And the channel is this one. All right, prettier. I don't know what you think you're doing, but that is not it. Okay. So let me go grab my OAuth token. Right click like. Can't remember where I get that from. Oh yeah, that's right. All right. Just a second. Going into secrets mode. I need to change that fun fact on there. I'm gonna rotate out or something. Okay. Oh wait, I need to do it with the other. One moment. I have to actually do this with my login for the bot. Okay, I can bring y'all back in now. There we go. So the name of my token here is gonna be, dang it, that didn't work again. Oh yeah, process env. Process env Twitch token. That should be correct. So what's next? Yes, new client with the opts. Great. Register some event handlers. Connect to Twitch. It's all pretty straightforward so far, right? And then I'm gonna add a message handler. Yep. I see what's happening here, okay. And I'm not doing anything with the on-connected handler. Oh, okay. All right, fine. I'll add the connected handler too. Oh, sure. Let's, you know what, for the sake of sanity, we'll just run the demo for the dice command. I'm sure that, whatever. See if my configuration is right. I'm gonna remove, where's my Twitch highlighter bot? Oh, never mind that. Never mind, go away. So let's actually run index.js and see what happens. It's connected. Is it in? Okay. I'm getting a connected to. So now I should be able to, if this worked on the first try, I am going to be amazed. If anyone says dice, Cyan Panda bot, you rolled a 4. Oh, cool. That worked on the first try. Never happens to me. It really does not. So this is a monumental event, folks, and you were here to witness it. The dice command works. Dice. Win. Thank you, Robert Tables. Appreciate it. Roll the 3. Kapow! All right, and so I'm seeing, actually, as y'all are chatting, I'm seeing, and I don't know if you can see in the console, but stuff is coming in. First try, PogChamp. I love it. I think I should probably end the stream right now because I'm just going to get myself pissed off if I keep going. That's pretty sweet. So let's keep going. What I want to do now, and I'll keep the dice thing in here for now, that's fine. But if the command name is, we're just going to do a quick wire up to the particle device cloud using my credentials. Quit while you're ahead is always a good plan, right, Frackberg? If that were the case, I would end every work week at around 11 o'clock on Monday, right? After I just get a little bit of email done, catch up on some things, and I'm like, you know what? It's not getting any better than this. I'm out. Ooh, so, oh, rolled a 6.com. Good job. All right, so the command I'm going to do here is online for now. I'm just going to go to the particle device cloud. So query device cloud for the number of devices Brandon has online. This is just the table stakes command, right? The next command would be, we'll add another one here for chase. And that will turn on the light chase command. And then we'll add another for, this is all just thinking out loud. Color. Maybe, I don't know. We can always change and refactor these later, but that's what we'll end up doing. Okay, so this is the piece where we need, I always have to go into the docs. Always have to go in the docs. For the particle JavaScript API. Where'd it go? JavaScript SDK. And I don't know if I said it, .com, but thank you for the kapow. I always love the kapows. Yep. Okay, yeah, particle equals new particle. Particle equals new particle. What? Sorry. Let's just call it this. So const particle equals new particle, right? Oh yeah, that's right. Kind of lowercase. Not a. It's okay. All right, and const token equals process.end dot particle token. So since this is under my account, I'm not gonna do any like login with your account thing because this is ultimately just gonna access my stuff. So that's what we're gonna do. And instead of logging in, I'm just gonna pass along the token, right? So the way that this works is when you run the devices command, I will run, we're going to do it this way. Do I have to do this whole thing as a, oh, I know. We'll do this. Right. Okay. Do number of devices, and we'll just do get online devices. Right? And then I will do client.say target. Brandon has num of devices online. All right. So function get online devices. Right. All right, so the command that I'm calling here, or the function I'm calling here is particle list devices with my OAuth token. That is going to give me an array of devices that I'm just going to do a count on, and we'll be good to go. S. Schneiderbach, thanks so much for the follow. I appreciate it. That's awesome. Hopefully I pronounced your name correctly. But thanks so much. That's awesome. I appreciate you coming in today. We are writing a Node app that actually controls that'll work on, well, a Node app chatbot for Twitch that'll control these lights on my wall. That was a mangled description. I'm so sorry. Ugh. That's fine. That's totally fine. But yeah, y'all get the idea. All right. So await particle dot get, what is that? List devices, excuse me. Right. Auth token. So I will have my list of devices, and I'm going to set that, well, let's just do here. Wall of things, you can control the LED sneak. Yes. That's what we're getting to, Siva. Thank you. So I'm going to wait for my list of devices, but that's not what I'm going to return. So that's going to be a device list, and I will do let device count. Oh my gosh, come on, Brandon. All right, and then once I have that, it's basically just going to be a matter of device. Well, let's do this. Device list. Just count, right? Right? Should be. Can't remember in the API how this ends up coming back. Let's find out. Okay. Yeah, Siva, I think, yeah, maybe it is length. You know, I will say, one of the challenges of switching between C++ and JavaScript all the time, and I was writing Python last night, and what is this stupid camera doing? Is I totally forget simple syntax things, like, all the time. But it's totally worth it. I know, it's totally worth it, but it's hard. Okay. Oh, proc-s is not defined, and I do need to get a token in here as well. I also forget how to spell things. I'm gonna get a token, and I'm gonna paste it in, so, you know, secrets. I know that. I was using ES6 syntax to build my Flutter Dart and Dart syntax in C. Right? And here I was actually thinking about trying to learn Go. I just make it worse for myself. But it doesn't matter. Like, who cares? Like, we all, you know, we have the tools to help ourselves, you know? Yeah. .com, nice try. That's pretty funny, .com. Oh, man. OPSEC fail of the week. Token. I'm gonna add that command. I'm gonna add a snark. I'm gonna add some snark on that. If command name. And we'll implement this later. All right. It was just to remind myself. Okay, so we should be good now. Let's come back over here. Connected. Sweet. So now we will say, what is it? Online. No, not that. Not that. Online. Unknown command. Oh. Thanks, Siba. There's not really... Well, you know, I guess I could move the camera over here now that I'm not really doing anything in the command line. This is the challenge. This is one of the challenges of Twitch, I think, is getting all the various screens in the right places. But thank you for letting me know. I appreciate it. So this is what I'm doing right now. Online. Unknown command. Really? If command name equals online. Y'all can see it, right? Brandon has object promise online. Yes, he does. But that doesn't make any sense because I awaited. Oh, wait. Hold on. That doesn't make any sense. Number of devices, get online devices. What am I doing in get online devices? Did you await on? Yeah. I'm async. I'm going to wait. Oh, yeah. Well, no, you know what, though? I shouldn't have to wait here, too, do I? I do. Yeah. Yeah. Thank you, Siva. And then, like, await up, async, await up the chain. Line 33. How come it's not highlighting line 33? You know what? Because I'm using the same bot here, it's probably overriding the, yeah. I didn't think it would work with bot sharing. That kind of makes sense. All right, so I did add that. Let's get back online. Brandon has undefined online. Yes, that's more like it. That's more like it. So console.log JSON.stringify. Can you tell me unknown command again? It's saying unknown command, and yet it's doing it. Okay. All right. Online. Okay. All right. Well, the call is working. Oh, I always do this to myself. Thank the maker for console logging. I have 57 devices online. Oh my God. I don't even think I realized that. 57. That's a lot. That's, 57 what? There's no context, but I have 57 devices online. Good gravy. They're not all in this office. I don't think. Or are they? Oh, Frackberg. This local network here. Oh, man. Okay, cool. So here's what I want to do now. I am gonna on my, so all of these devices are on a mesh network that's on, it's basically, it's on an LTE, it's on a cellular device. So I have these 4 strips here. This is the gateway device, and this is actually the device that controls the modes. So if I change the mode here, and let me go back over the firmware. Just a second. If I go back over to the, firmware, my modes are random, trellis, pixel, rainbow, and chase. So rainbow is number 4. So if I go change this to number 4, yeah, so that's actually going to change the way that these work with some weird artifacts. I don't know. Are y'all seeing? I'm seeing that. Interesting. Okay. That's fine. It's not fine, but we pretend like I don't know what's going. It's fine. So what we're going to do here is when you pass in a chase command, I'm going to run what I'm going to do is I'm actually going to run this set mode function and then call the chase function. So we're going to call 2 different. Did the particle console list 57 online? If I go to my devices, AT Delta Dan, thanks so much for the subscription. That's awesome. I appreciate you subscribing with Twitch Prime. Very cool. Thank you. Thank you. You now have the ability to use the Cyan Trash Panda, which I please do use all the time. I'm going to do my little hype thing and hope that it doesn't overload chat like it did last time. Oh, .commie, thank you. You are free to use that and hang out. Thank you so much. Yeah, 57, .commie right there. Same number I'm getting from the console. So that's good. I haven't double checked that. So I want to call a function. This is the way call function looks, or what it looks like ultimately. Is just particle call function. You pass in a device ID, the name, argument, and token. My device IDs are, I'm going to set those as, I'm going to set the main device. It's not a, device IDs aren't a secret, frankly, because you can't, knowing the device ID doesn't give you anything. However, I'm going to set it in my env so that I'm not hard coding it here. Right. So just a second. Because I'm going to open my secrets, but I want you to see them. All right. Show desktop. .commie, the Michael Jolly, y'all are hilarious. Y'all are cracking me up today. Oh, y'all are funny. OBS, go back one scene. You guys are some regular Twitch pen testers right here today. I love it. Kill 57 devices. I appreciate the good-natured desire to help secure my applications. Y'all are great. Const watt controller. Michael Jolly. That's great. Social security number. Visa card number. Okay. So when you issue the command chase, so what we're going to do is set mode to chase. Call. One of these days I'm going to hit the jackpot on someone's stream. You are. It's good. Your brute force attacks eventually will work. I'm certain of it. Oh gosh. It just occurred to me, I need to wrap these things and try catches since I'm doing async await. Why not? Let's just output the error. Brandon wrote crap code. I'm not actually going to emit the error. I will log it. So, the Robert Tables, I know you came in a little bit late today. These are my coding safety glasses. This is all, .commie deserves some of the credit for this as well as another viewer. I don't know if he's here today. Yes, I was joking a few weeks ago about how I never wear safety glasses when I'm soldering. And there was some jokes in chat about I really should wear them when I'm coding. So these are my fancy coding safety glasses. They're not for the monitor, and frankly, they hurt my ears, and I take them off the second the stream is over. But yes, they are my coding safety glasses. All right. All right. Okay. Safety is paramount and code is dangerous, especially the code that I write. All right, so I don't know that I really cared. I'm not going to care about the return types here, so I'm just going to do particle, we'll do async, particle dot call function. Let me make this a little smaller. There we go. My device ID is... Oh, the Michael Jolly, thanks so much for the subscription. Y'all are so awesome. I love that I'm getting to see some David Tennant today. Thanks so much to Michael Jolly. I really appreciate that. And see if it there for coding. Such a sparkling. My gosh. No, Siva. They don't. They protect me from all the bad code. They don't help me write better code. I need like an implant. I need an implant for that. Boy, wouldn't that be great? What did I call it? Watt controller. Maybe they help me see the control. They help me see Control C, Control V better. How about that for my copy paste code? That's what they do. All right, so the name of my function here is, and I think this is going to be a good spot to wrap once we get this working. So if y'all don't mind, I'm going to go a little bit past 2 o'clock today. Why not? Let's do it. Because I feel pretty good about finishing this up. Okay, set mode. My argument is going to be 5. That's crazy talk. I know. So just like give me 5 more minutes. Not 2 hands, just 5 more minutes. 5 more minutes. That's all I ask. Just 5 minutes. All right. And then we're going to do the same thing, but we're just going to call the chase. Those flickers are still ticking me off. I don't understand what's happening there. That's okay. And we'll call chase. This one does not need an argument. Right? No, it does not. And then we'll say some stuff. What am I since the mention, this has been compared to Snake a few times, I guess I have to call it that. So look at, I don't know. I'm not inspired right now. I'll change this later. The lights are chasing each other. Okay, great. We got to clean that up. Ugh. Do not love. All right. All right. Oh no. Particle dot. Huh? Oh, does it not like it because I'm doing. Ugh, fine. I don't think it likes it because I'm not actually doing a return. But I don't care. I don't need it. At least not right now. Maybe I will. Still doesn't like that. Oh, because I have to set it to something. Fine. Oh, doesn't. Yeah. Don't use those reserved words. Don't do it. Don't do it, everybody. Unexpected token. Oh, yeah. Boy, not much actual code gets written around here. Really? Hold on, what am I doing wrong? Oh. You know, I haven't had any of that after all. It's not async, it's wait. Ugh. Unexpected token. And yeah, return keyword. I like it. There we go. All right, what's the command? Chase. Of course, this is only gonna be able to be run like once. So I suppose you could like turn it off. Aha! Yes, he did. No, it's not defined. Oh, boo. Y'all are gonna be seeing that one a lot. Ugh. Yeah. Yeah, Siva, you're right. I don't care enough to do it though. Unknown command chase. Well, no. Really? Oh, it's this business here. That's why it's doing that. Gonna have to put on a mute if the a mute of the bot if it doesn't use a better tone of voice. You're right. This bot is not being very nice. Not being very nice to me. Block Cyan Panda bot. I didn't get a response that time. It's running. Oh, timed out. Okay. Why? $400. Do I have the right device? Device is set mode. Got a 400 from the set mode on that device. Did I pick the right one? Maybe I didn't. E0FF. Yeah, that's the right device. / set mode. That is strange. Yeah. I take off the glasses. They're hurting. All right, if I change the mode. Oh, 400 because it's offline, maybe. That's why it's being weird. Give me a second. Yeah, so my device has decided to go offline for a minute. Which is, of course they did, right? So let me get this back online. All right. Oh, yeah, there it is. Okay. It's back online. I'm going to have to account for that. No, they're not. Oh, yes, they are. But they're being really weird. Ugh. Hold on. No, there. Now it's working. Sweet. So Chase works. All right, cool. That's a good stopping point. So running the chase command will I don't know if it'll like start over at this point. So the next thing will be like stop. We should probably add a command for undoing this. Kapow, kapow, that's right. Thank you, Dr. Cumming. If command name equals stop. Collapper. Ah, Robert Tables, yes. Chase stop. And then I want to add, we're gonna have to actually change firmware to do the setting the color to something different. Right now it's hard coded to cyan, of course, but we can actually make that programmable. And I want to do that via the chatbot as well. So let's do that on Thursday. Let's pick that up on Thursday. Ice Ice Baby. We need an Ice Ice Baby command, definitely. So we got the beginnings of a Twitch bot. That's kind of cool. And I'm pleasantly surprised with how easy that was on the TMI.js side. That's kind of cool. And I'll keep the dice command in for a while because at least, you know, that's kind of a fun thing to add. So nice. All right. So I think what I want to do as I wrap up, I know we were kind of in a bunch of different directions today. I do appreciate y'all helping me out on the firmware side with Brew Buddies. We wrapped that up and then starting to work on this. I'm pretty excited about everything that I want to add to the wall over the course of the next couple of months. So that should be good fun. And yes, 2 hours and 15 minutes. I think it's probably a good time to stop. I'm looking to see who's streaming right now. To raid, it looks like we got Adam13531, which is, he's always fun to watch. And then Raimu8354 we've jumped into before. He's actually doing a game in C++. Let's jump into Adam's stream. I think I saw this morning he was starting to work on sort of a crazy bug. So a git link for the wall device code. Thank you, .commie. Let me add that real quick. I will add that in and I'll do a push here in a minute. Let me start the raid. I'm not gonna like trigger the raid. And then I will give you all the link to the wall device code. And I will add this to my panels, to my Twitch panels as well, since this is gonna be the new project. There it is, GitHub, Wall of Things. I'll push this out there, but this has the current firmware that's out there right now. And yeah, so let's pick this up on Thursday. Thank y'all for coming and hanging out. I had a lot of fun today. Thank you, Michael Jolly. I appreciate for saying that. Fun stream. It was fun for me as well. It's cool to chat with you all as always and to get a bot involved as well. So that should be good fun. Now, y'all have a great rest of the day, and I will see you again on Twitch in other streams, definitely later this week, and then again on Thursday. Have a great rest of the day, everybody. Thanks. Bye.